In this problem, we're given a graph of f of x, and we are to find the average rate of change of the function f of x and determine when is that average rate of change negative, positive, or zero, depending on the interval that we're looking at. So let's look at the definition of average rate of change. It turns out the average rate of change is defined to be the slope of a secant line. A secant line is simply a line that passes through 2 points of a curve. The slope of that secant line is defined to be the average rate of change of the function f over the specified interval. So for example, in part A, they're saying let's look at the interval from point B to point C and determine if the average rate of change is negative. Since the average rate of change is the slope of a secant line, and a secant line is simply the line connecting points B and C, let's draw a line through B and C. And once you do that, you notice that the slope of the purple line, which is the secant line, drawn through points B and C, the specified interval, the slope of that line is negative. I can tell because if you want to go from point B to C, if you were to go to the right, you have to move down to get to point C. So the graph and the secant line is obviously decreasing. It has a negative slope. So the average rate of change of the function is definitely negative between B and C, so I will check that box. I notice quickly that B and C is an interval for the next two parts, so I'm going to skip down and do those now. Since the average rate of change was negative, it can't be positive and it cannot be zero. So we won't be selecting those when we get down to those parts. That brings us to the interval B and E. If you were to connect a line from point B to point E, it would be a horizontal line, and horizontal lines have a slope of 0. So between B and E, the slope of the secant line is 0. There's no change. The y value at point B is the same as the y value at point E. On average, there was no change. Therefore, between B and E, we can say the slope is not negative and it's not positive. It would be 0. So we are going to say that the slope is 0 between B and E, which means we will not be selecting these boxes here. The next interval I'm seeing is B and F, which is in part A and part B of the problem. Let's draw a secant line through the points B and F, and that would look something like the red line I just drew. Clearly the red line is decreasing, so although within the interval between B and F, that would be between the x value of this point and the x value of that point, over that specified interval, although the function is decreasing and then increasing and then decreasing, we're asked what happens on average. And obviously, since the secant line is decreasing, it has a negative slope. So on average, the function is decreasing. The y value on f is certainly lower or less than the y value at point B. So the average rate of change between B and F is definitely negative. So we'll be selecting this box, which means we won't be selecting this one because the slope was not positive. The next interval I see is between B and H. So let's draw a line through B and H. And clearly when you draw a line through B and H, you get a line that's increasing, which means it has a positive slope. The y value on point H is greater than the y value on B. So even though the function was decreasing, then increasing, then decreasing, and then yet increasing again, that doesn't matter because we're asked to find the average rate of change, and on average, it increased more than it decreased, which is obvious because H is higher than B, so its y value is greater. So between B and H, the average rate of change of f of x was not negative, it was positive. So we won't be selecting this one because that says it was negative. We'll be selecting this one to say it is positive. Notice that we have a none of these choice in both parts A and B, but I won't be selecting that because we already selected one of the answers in both of those parts. So there's a couple more intervals to look at. The next one is D and E. We haven't looked at that. Let's draw a line connecting D and E. And when you draw the secant line through D and E, it's clear that the slope of that secant line in red is positive because the line is increasing as you trace left to right. So between D and E, we're going to say that I will not select that box because this says that the average rate of change is 0, and it clearly was not. It was positive. So the final interval we need to look at in this video is D and F. So let's draw a secant line connecting D and F. You may notice whenever I draw a horizontal line, I do it by hand, so it doesn't look so well. For some reason, the software I'm using, when I draw a horizontal line, doesn't quite go through the 2 points that I want it to. So, but you get the idea. If you were to connect a line between D and F, you would get a secant line that is horizontal. Oh, look at that, it drew it for me. And as I said before in this video, the slope of a horizontal line is 0, which makes sense because on average there was no change. The y value on f is clearly the same as the y value of d. Those points have the same height, if you will, or distance from the x-axis. So since there was no change over the interval, or I should say there was no change on average, between d and f, whatever the x value is of point D and whatever the x value is of point F, that would be the interval on the x-axis for which you're finding the slope over. So over that interval on the x-axis, we concluded the slope is 0. So I'm actually going to select this box because it says the average rate of change of f of x is 0. And then of course I will not select the none of these choice because we selected at least one of the boxes in that problem. So as long as you know how to connect two dots with a line, and as long as you know that an increasing line has positive slope, a decreasing line has negative slope, and a horizontal line has 0 slope, and as long as you know the slope of that secant line is defined to be the average of change, this problem should be pretty straightforward.